So we've seen parabolas, we've seen ellipses, and now finally we're going to be looking at hyperbolas. Now hyperbolas are going to be pretty much brand new to us. Now they come in two different forms. Now we're used to the equation, now x squared over a squared plus y squared over b squared is equal to 1. That's the equation. If a and b are different, that's the equation of an ellipse. If you change this sign to a minus, then that changes things in the sense of the curve is no longer an ellipse. This curve is now a hyperbola. Now, what does this look like? Well, first of all, if I say that y is 0, then I can say that x is going to be equal to plus or minus a. So when y is 0, x is equal to plus or minus a. So I can definitely say that the curve goes through those 2 points. Now, what we also find is that a hyperbola has asymptotes, and the equations of the asymptotes are given by x over a is equal to plus or minus y over b. This is given to you in the formula booklet on page 5, it's in the table. So these are the equations of the asymptotes that we're looking for here. So what they give you are two asymptotes, both of which go through the origin. Okay, it's my poor attempt at a dotted line. Okay, so you can see they both go through the origin, and the hyperbola curve must therefore, going through A on this side, then tend towards this asymptote and get closer and closer and closer to it, and likewise along that edge. For here, it will go closer and closer to this point, and likewise along here. Now the tendency, and what I see a lot of students doing, is they sketch the curves first and draw them as if they are parabolas. Okay? But when you then draw on your asymptotes, the curves clearly don't tend towards those lines. Okay, they're veering off in different directions. So it's good practice to try and draw the asymptotes first rather than drawing the curve first, because that can be misleading. Now, as you can see, that's one version of it. Now, there is a second version, because it could be that instead of x squared over a squared minus y squared over b squared equals 1, we could have the y's round the other way, so x and y round the other way. So y squared over b squared minus x squared over a squared is equal to 1. We could have it that way round. So what we find here is that when x is 0, we have y is plus or minus b. So when x is 0, we have plus or minus b. So b and minus b. Now the equations of the asymptotes are still given by this equation. Okay? Still given by x over a is equal to plus or minus y over b. So we can draw in the asymptotes this time. Okay, not very accurately done, but just to get an idea of what this shape will look like. So that if it's going through this point, the curve must do something like this. Okay, so you have two different variations here. You've got the y squared being negative, or you've got the x squared being negative. And that changes and flips which type of hyperbola you're considering. But the equations of the asymptotes are still given by the same equations. Okay? So we're going to be looking at sketching these in more detail and looking at particular problems in the following videos.